In today's lecture, we are going to start ellipse. This is the first lecture of ellipse, and in this lecture, we will mainly focus on the basic definition, derivation, standard forms, shifted standard forms, rotated standard forms, and some questions on that. Now, welcome back again. Now, it is my re-entry into English. We will start the chapter. Okay. Now, this chapter is actually a very important chapter both from mains and advanced point of view. You might be wondering, I keep telling the same statement before starting any chapter, but that is right, every chapter is of course important, but from the ellipse and hyperbola every year we are getting at least 1 or 2 questions at least in main standard, and in advance also we keep getting questions. And you already know that coordinate geometry is already a bankable subject. That means if you know how to solve questions, you can solve any question. Maybe it will take time or it will not take time, but it guarantees you the answer. So that is why coordinate is very, very important. Even during our time when we used to prepare for subjective IIT papers, we used to bank on coordinate geometry. So out of 12 questions, we used to get at least 3-4 questions on coordinates, so we used to crack all of them. Okay. So now, can we start? So first, what is the definition of ellipse? So here you already know the definition of conic. So it is locus of a point P which moves such that its distance from a fixed point and its distance from a fixed line are at a constant ratio. Now this ratio must be less than 1 for the curve to be ellipse. Here that ratio is called as eccentricity or eccentricity, and it has to be less than 1. And remember that E is a constant. What if E varies? If E varies between 0 and 1, what do we get? We will get many such ellipses. Okay. So we will work out with that little later. First we will try to understand the meaning of this definition. So now there is a focus here, there is a point P here, and there is this line. This point P is the variable point which is moving. This fixed point is called as focus, this fixed line is called as directrix. P is moving such that distance of P from S and distance of P from the line are at a constant ratio, and that is the E. Now because E is less than 1, this distance is definitely less than this distance. Now as P varies, we will get a closed diagram here. Okay. So now what is the guarantee of the closed diagram here? So for that I will give you one simple thumb rule. So for example, let us say we take this point A divides S and Z, A divides S and Z in the ratio, what is the ratio? E is to 1. We can also find another point on the same line which is this, which is let us say A dash, which will divide S and Z in the same ratio E is to 1, but externally. So that means 2 points are already possible. So whatever is the curve, it has to turn back and it has to close the diagram. Okay. So this way we can justify why it is a closed diagram. Okay. Now further, we understood what is the definition. Why is the diagram closed? Okay. So here that is exactly the next page, shape of an ellipse. How would the shape be? Shape would be a closed diagram, and here we also learned why will it be closed. Okay. Now let us look at variation of E. If E is equal to 1, we will get one parabola. If E is equal to 1, we will get one parabola. If E is less than 1, we will get an ellipse, but E is a constant. If we vary E, what happens? That is one general knowledge point. Suppose let us say we have one, we already have a diagram here. Okay. So we are basically exploring what happens if E is varying between 0 and 1. So for E equal to 1, let us say we get one parabola like this. For E less than 1, and if E is one particular constant, we are getting an ellipse like this. Suppose if E is 0.5, we got this ellipse. What if E is 0.6, we will get another ellipse. What if E is 0.7, we will get another ellipse. So like this we will get many ellipses here. Okay, we will get many ellipses like this. Okay. So, if E is varying between 0 and 1, it should cover the entire region here. Okay. So, if you combine all those ellipses, it should cover the entire region. Okay. So, that is for your general knowledge point. Okay. Now, let us go to the standard setup and the terminology. Now, this is my let us say directrix, this is my let us say focus. We generally denote focus with S, and because this is a closed diagram, there exist two foci in it. Focus is singular term, foci is plural term. So, there will be another focus here which is named as S dash. Sometimes this S is also denoted with F and this S dash is F dash or F1, F2, but you can use any notation, it does not matter. Okay. Now, this point which is closest to the directrix is called as the vertex. Now, for this focus, this is the directrix. For this focus, this is the directrix. So, this point which is closest to the second directrix is named as A dash. Okay. Now, A and A dash are the vertices, one vertex, second vertex. Now, when we are applying the definition of ellipse, so let us say I am taking distance of P from this focus and distance of P from this directrix, the ratio of these two must be equal to E. Now, suppose let us say you take the distance of P from the S dash and take the ratio of this distance to this distance, then it will not be E. You have to follow the rule that this focus has this directrix and this focus has this directrix. So, if you want to compare them, you have to compare it with this distance. Okay. So, these two will be in the ratio E, but these two will not be in the ratio E. So, remember that for this focus corresponding directrix is this, for this focus corresponding directrix is this. Okay. So, that is one basic idea of directrix and focus. Now, this point where this line which is joining both vertices meets is also called as foot of the directrix. So, here also we have another foot of the directrix, this much is clear. Now, this A dash is also called as the major axis. Okay. So, basically this major axis is one axis of symmetry. So, whenever we want to define axis of any curve, remember that all axes are lines of symmetry. For example, here for ellipse there are two lines of symmetry. One is this A dash, the other line of symmetry is this, which we can name it as BB dash. Okay. So, these lines of symmetry are called as major axis and minor axis. Basically, ellipse has two axes of symmetry, one is major, one is minor. So, A dash is called as the major axis, BB dash is called as the minor axis. Now, point of intersection of these two is called as the center of the conic. Okay. So, for this point is the center. Now, we can define center as the point of intersection of the axis of symmetry. But if you go by SL Looney, the definition goes like, it is the point where all chords passing through it get bisected at the same point. But that is fine, that is based on the chords, we have not yet reached chords. So, we will learn it when we are doing the chords. Okay. But it is very simple, it is the point of intersection of lines of symmetry. Okay. Now, going on further. So, if I join any point from the focus, then this distance is called as the focal distance, you know this. If I join from the center, it is called as central distance or radius or central radius. This PS is also sometimes called as focal radius, that is fine. Now, an ellipse can have a chord, it can have a tangent, it can have a normal also, all are possible. Now, the chord which is perpendicular to the major axis and passing through the focus is called as the latus rectum. Now, how many latus rectums are there for the ellipse? There are two. In fact, we cannot call it latus rectums, we have to call it latera recta, that is the plural term. Okay. So, it is latera recta. Okay. Now, in fact, In Latin, latus rectum means length of the chord. Okay, so when we are talking about latus rectum, we don't have to say that length of latus rectum. It is naturally latus rectum means there is already length involved in it. Okay, so this is the latus rectum. We have understood the basic ideas. Now, when we want to generate an equation of the ellipse, let's say, then this entire setup has to be put at some point which is more accessible to us and which is algebraically also is very simple. So, one such point is the origin. So, basically we take this ellipse and we place it at the origin. Now, when we are placing it at the origin, we make sure that the center is at the origin. Okay. So, to derive the equation, we make sure that this center is the origin and this major axis is x axis, this minor axis is y axis. We will make sure that setup goes like that. But before that, you have to understand the basic ideas of the foci, center, ends of major axis, ends of minor axis, directrices, latus rectum. Okay. So, now we will proceed to the deriving the equation which is the standard form. Okay. So, to derive the standard form, we also have to understand the setup which I have explained, that the center has to be origin and major axis must be x axis, minor axis must be y axis. So, let me again go back and use the same diagram. Okay. So, I will just remove the parts which are not required for me and I will explain it using the same diagram. Okay. Okay, so now let me explain it using the same diagram. We have taken this as x axis, we have taken this as y axis. Okay, so we have to remove that latus rectum also. Now, center is origin, so let us fix some coordinates for this. Okay. And we generally take major axis and minor axis as with notation small a and small b. So, here because we named this point as capital A, we take the point as small a. Similarly, we named this point as capital B, so easy to remember if we name it as small b. Okay. So, similarly, because we have taken origin here, a dash will become minus a comma 0 and b dash will become 0 comma minus b. This is the simple setup. Now, we know that diagram is closed this side compared to A. If we compare it with starting from the origin, diagram is closed towards the origin. So, from the origin, if we compare these two distances, distance of focus from the origin, distance of vertex from the origin, focus should come before the vertex. So, we will take help of E. We know that E is already less than 1. So, we design focus here as AE comma 0. So, this is a designed coordinate. Remember, this is designed coordinate, designed by who? Mathematicians who built the concept of ellipse at initial stages. That could be centuries ago. Okay. So, why did they do it like this? For easy calculation purpose. Okay. Now, that S is already designed. In fact, if you also look at the entire ellipse, we are basically cooking this at the origin so that our algebra becomes simple. Okay. So, whenever we want to solve any question on ellipse, we always make sure that entire setup is put at the origin. That happens with the circle, parabola and every curve also. Okay. Okay. So, now based on the definition, we will derive this foot of the directrix. Suppose if we name this as Z, we can derive Z using the definition of ellipse, which says because A point is already on the ellipse, so this AS and AZ, these should be in the ratio E:1. Now that we already know A and S, if I let us say take Z as small z comma 0, I can get the coordinates of the point Z using the definition, which shall be like this: A minus AE divided by Z minus A must be equal to E. because these two distances must be in the ratio E. So, further we can find the value of Z. So, here A minus AE is equal to Z into E minus A into E. AE gets cancelled and we will get Z equal to A by E. So, which means coordinates of this point, which is the foot of the directrix, is A by E comma 0, which will make the equation of this directrix to be x equal to A by E. Because this line is parallel to y axis, x must be constant on that line. See, if you notice here, we designed S, we calculated Z. So, S is the main design point here, okay. And similarly, now that we have derived everything for RHS, right hand side, we can also get it for LHS. So, for this it is minus A E comma 0 and this point is minus A by E comma 0. So, which will make the equation of this directrix to be x equal to minus A by E. So, this is the setup. Now, in this setup, before I go for the derivation of equation, let me explain some terminology here again. Because we have taken origin to be the center, major axis to be x axis, minor axis to be y axis, the chords which are already parallel to y axis are called as double ordinates. What is the meaning of ordinate? Ordinate is not y coordinate. Ordinate is not y coordinate. Ordinate is the perpendicular drawn from the point to x axis. Now, here in this chord there are two perpendiculars, one perpendicular drawn from this point to x axis, another perpendicular drawn from this point to x axis. There are two ordinates involved here, so hence it is called as double ordinate. Okay. So, double ordinate means chords parallel to y axis. What about double abscissa? It will be the chord parallel to x axis. So, what is the meaning of abscissa? Perpendicular drawn to y axis. Now, there are two perpendiculars involved here, so hence it is double abscissa. Okay. So, this is the meaning, and latus rectum is also one of the double ordinates. Similarly, this latus rectum is also one of the double ordinates, you know this. Now, chords will pass through centers. If chord passes through focus, they are called as focal chords, you know all that. Okay. So, here just this explanation part was left, so I have just covered it. Okay. Now let us get back to the derivation. So, if P is any variable point on the ellipse, let us say I take this point as x comma y, then this point must satisfy the definition, which is distance from the focus must be equal to E into distance from the directrix. So, that means we can write an equation here. Okay. So, we have one page, extra page for this, so we will just use this page. So, this equation is x equal to A by E. So, we can get this, we can apply this condition and get a relation. Okay. So, PS by PM must be E, and we know that PS is going to be the distance between these 2 points. So, we can apply the distance formula, which will give us x minus AE whole square plus y minus 0 whole square divided by, what is the distance of this point from this line? It will be the difference of only x coordinates, because this point M will have same y coordinate as the P, because both are at same level. So, we can just take the difference of x coordinates, which are like A by E minus x. If I am writing A by E minus x, then definitely x is smaller than A by E, it is already a positive number, but still I am writing modulus. Okay. So, this must be equal to E. We now square it and simplify it. Okay. So, when we square, what do we get? X square plus A square E square plus, no, we will get minus here, minus 2AXE plus y square is equal to, in RHS we will be getting E square into A by E minus x whole square. Now, further if we simplify it, what do we get here? A square plus E square into x square minus 2AXE. Okay. So, because when e square multiplies we will get this. Okay. Now, see if there are any terms which can get cancelled. So, here this 2axc, 2axc are getting cancelled. Now, take all variables to LHS, take all constants to RHS. That is our standard idea of simplification. So, when I take all variables to LHS, so there is one x square here, there is x square here. So, we get x square into 1 minus e square. There is only one y square term and there are two constant terms, one is a square, one is a square into e square. So, when we take these constants to RHS, we will get something like this. Now, if I divide with a square into 1 minus e square both sides, what do I get? X square into 1 minus e square by a square into 1 minus e square plus y square by a square into 1 minus e square equal to a square into 1 minus e square by a square into 1 minus e square. This will come out to be 1. Okay. Now, here 1 minus e square also gets cancelled, you know this standard drill. Okay. Now, we name this a square into 1 minus e square as b square. Okay. So, that means here it becomes x square by a square plus y square by b square equal to 1. So, here I am saying we named it as b square, but here I explained that 0 comma b is designed, but both will be in consistence with each other. Okay. Okay, so, now there is a relation between a square and b square. Using this we can get the eccentricity. Okay, so, if we want, let us say e square from here, we can write it as 1 minus b square by a square. So, using this we can get the value of eccentricity whenever required. Okay. Now, other than this, now that we got an equation for the ellipse, we can derive all points that we want. For example, here what are the points that we want? We are more interested in, we are more curious about the ends of lattice rectum. So, suppose if we want to find the ends of lattice rectum. Now, what is the idea? These lattice rectums, these latera recta are basically double ordinates on these lines which are parallel to y-axis. X will be constant. Now, what is the value of x for the focus, which is AE? So, it will be maintained for this line entirely. For example, suppose let us say if I take it here, because this side it is already filled. So, the x coordinate of this point will be minus AE, we do not know the y coordinate. Here also we know the x coordinate, but we do not know the y coordinate. If you want to calculate it, we put minus AE in this equation and solve for y. So, if I put minus AE in place of x, what do I get? A square e square by a square plus y square by b square equal to 1. So, here a square gets cancelled, I can take e square to that side. So, y square equal to I will get b square into 1 minus e square, which also can be further written as b square into, you see here 1 minus e square is b square by a square. So, here also you can observe. So, it is b square by a square. So, y becomes plus minus b square by a. So, these 2 points will be, here it is minus b square by a because it is in third quadrant, y has to be negative, and here it is in the second quadrant, y has to be positive. So, it is b square by a. So, using this we can also get the length of the lattice rectum. So, what is the lattice rectum here? Lattice rectum is always 2b square by a. Okay. Now, when we are building the formulae, let us say this becomes one formula. When we are building formulae, how do we identify which value is b, which value is a? For that, when you look at any equation like this, x square has one constant below and y square has one constant below. Out of these two, you have to check which is the bigger one, which is the bigger value in terms of magnitude. That becomes the major axis. Now, based on that, you can design the terminology and eccentricity and everything. Okay. So, this is basic idea of the derivation, and this is the basic explanation of the setup. Okay. So, I hope you have understood this setup. Okay. So, if you want, take a snapshot of this so that you can make notes at later stage. Okay, so can we proceed now? This derivation must be done by you at least once at your home, because in coordinate geometry there is too much terminology, there are too many formulae. Now what is the best way to remember all of them? Best way to remember them is to derive all of them on your own. So that is the main secret of mathematics, that is to stay upfront and to stay updated with all derivations and formulae. What is the best way? Derive all of them on your own. Okay, that is how I remember all of them, and that's how I cracked IIT also. So it is better that you derive all of them on your own. Okay, so I would recommend that you don't copy this, you derive it on your own. Okay, so now let me explain one important property here on this ellipse. Suppose I have taken one P point here. Now that we already have the clarity of points, let me take this point as AE, 0, and this is x equal to A by E. This is S dash. Okay, so let us say I join these, okay, this point P and this directrix. Okay, let us name these points as, let us say, M and M dash, and this point is S. Suppose if I take this ratio PS by PM, it must be equal to E. We already know this because this is the definition. And also if I go for PS dash by PM dash, this also must be E. Now if I add PS and PS dash, okay, then what happens? It basically becomes E into PM plus PM dash, and we know that PM is this length and PM dash is this length. When we are adding these two distances, basically these two become the distance between two directrices. Now one is at x equal to A by E, other is at x equal to minus E by E. Now what is the distance between these two lines? 2A by E. So that means we can write this as E into 2A by E. So E can get cancelled, and what do we get here? We get 2A. So this is one of the most important properties of the ellipse. That means on the ellipse, from any point, if I join both foci, then sum of those two distances must always be equal to the major axis. Okay, this becomes a standard definition of ellipse, standard property of ellipse. So that means if I take any statement like this, okay, so forget the definition, just read this statement. P is a variable point, A and B are two fixed points. Okay, so suppose let us say A is here, B is here. P is a variable point which is moving so that sum of these two distances is always equal to a constant. Now what is the locus of P? It is ellipse. But there is a condition. Condition is this K must be greater than AB. Why is this condition? Let us go back and check once again. Now AB are basically these two fixed points. Distance between these two fixed points, which is the distance between foci, is 2AE. And what is the sum of PS and PS dash? It is the 2A, and we know that E is already less than 1. So sum of these two distances must be greater than 2AE, because 2A is always greater than 2AE. So that is exactly why this K should be greater than AB. Okay. So now it is your job to explore what happens if K is equal to AB and K is less than AB. Okay. So if K is equal to AB, what happens? If K is less than AB, what happens? These two you explore and tell me. Okay. So you might have given a thought now. Can I answer? K equal to AB will give us line segment joining A and B. K less than AB will give us nothing, because when we add any two distances like this, then sum of these two distances must be greater than or equal to the third distance. What is this named as? Triangular inequality. So, by triangular inequality, PA plus PB must be greater than equal to AB. So, if that constant is less than AB, then that means that locus represents nothing. Okay. So, that is for your general knowledge. So, in general we can say that locus of any point on the plane, in a plane which moves such that sum of its distances from fixed points is constant is an ellipse, provided this condition is satisfied. Okay. Can we move on now? Now, using this definition only, we can also construct ellipse. Have you ever given a thought of constructing an ellipse? This is how we can construct an ellipse. First I will explain the process, then you can understand how it goes. Okay. Suppose let us say I have taken one thread, okay. So, simple thread, and I have joined the ends of the thread, I knotted it, okay. So, it looks like this. After I put the knot, it looks like this, okay. So, understand that there is a knot here, okay, or let us say we have one completely circular thread or something, okay. Now, if I fix a point here, let us say I fix this point with pin, okay. I put a pin here, okay, let us say this is the pin and there is thread here, and I take a pencil, I stretch the thread, okay. So, imagine that there is pencil here, okay, it is vertical pencil, okay. So, imagine that there is a pencil here, okay. Now, keeping the thread tight, if I move the pencil all around, what will I get? I will get a circle. So, this is the basic idea of drawing a circle without using the compass. Okay. Now, imagine that instead of fixing one pin here, if we fix two pins, we will get ellipse. Instead of fixing one pin, if we fix two pins, we will get an ellipse. So, how do we understand it? Let us fix pins here. Let us say there is one pin 1 here and pin 2 here. Now, we have taken a thread, same process. Okay. So, the thread is something like this, okay, and now my pencil is somewhere here. This is the pencil. Okay, this is the pencil. Now, the animation started before I started it. Now, keeping the thread length of the thread constant, if I keep rotating the pencil, if I keep drawing it, I will get one ellipse here. Okay. So, here you can also imagine that, the distance between these two foci, okay, so distance between these two foci is already constant. Okay. Okay, so distance between these two foci is already constant. So, remaining length of the thread is also constant because thread is already fixed, we are not varying the length of the thread. So, sum of these two distances must be constant for all locations of P. So, basically we are satisfying the earlier definition that we have learned, which is also a property of ellipse. So, using this we can actually draw the ellipse. Okay. Okay, so this is about how to construct an ellipse. Okay. So, I hope you have understood the idea. Now, we will move on with the standard terminology and the coordinates of general points and general discussion. Okay. Okay. So, this is the standard ellipse that we generally use 90% of the time to solve questions, and here whenever we are writing this equation, if our axis is major axis of the parabola is our x axis, then A must be greater than B. If B is greater than A, then the ellipse may look somewhat like this. Ellipse will look somewhat like this. Okay. So, here observe this, A is less than B. Okay. So, now let us go back and try to work out the terminology. So, we have had a very strong discussion about the terminology. So, let us just shortlist all of them, let us just take a quick review. So, center here is 0 0, we learned it. This is our x axis, this is our y axis, and vertices are plus minus a comma 0, that is fine. Foci plus minus AE, and equations of directrices. Okay, so this must be colon. So x equal to plus minus a by e, and length of major axis must be 2a, length of minor axis must be 2b. We already are aware of this, and a must be greater than b. Okay. Next, eccentricity or eccentricity can be calculated using this idea. Length of lattice rectum is always 2b square by a, and endpoints of lattice rectum, in fact there are 4 points which are ends of latera recta. So basically these are the points, and this is one important formula for focal distance. So just like the way we have a formula for focal distance of parabola, we also have a focal distance formula for ellipse and hyperbola also. Okay. So a minus e into x1 will always give us the distance of the point from first focus, and from the second focus a plus ex1 will give us the distance. So whenever we say that our first focus or second focus, always the focus in the right side is your first focus, focus in the left side is your second focus. Okay. So this is the standard terminology, and there is this property which is always satisfied. Okay. Now what happens if we shift this ellipse to some other location, but while keeping x axis and y axis parallel to x and y axis, if I shift the ellipse, then what happens to the equation and also the coordinates? So remember this thumb rule, whenever we shift the origin to a point, let us say h comma k, then in the equation in place of x, x minus h comes, in place of y, y minus k comes. Now in the coordinates of the points, for x h gets added, for y k gets added. In the equation there is x minus h, y minus k, but in coordinates we have x plus h, y plus k. Okay. So in coordinates they get added, in equation they get subtracted, simple rule. Okay. So now center becomes 0 plus h, 0 plus k. Now vertices become, earlier it was plus minus a comma 0, now h and k get added. Similarly for foci, h and k get added. So for all of them it is the same story, but lengths will not change. No matter where you shift your ellipse, lengths will never change. Okay. Next, length of lattice rectum also will not change, but endpoints of latera recta will change. See, h and k are getting added, and eccentricity also does not change because it is a constant, but focal distances will change because now the coordinates have changed. Okay. So when it comes to focal distances, these will follow the same logic of the equation. Remember this, always focal distances will follow the logic of the equation, not the logic of the points. Okay. It will not follow the logic of points, it will follow the logic of the equation. So we can straight away compare this like this. So here we got a plus ex, a minus ex. Now in place of x we are getting x minus h, so here we are getting x minus h. Okay. Okay, so now can we proceed? So there is this different ellipse which is the rotated ellipse. We can also take it as a rotated ellipse, or there is also a different way of understanding this. We can also take it as an ellipse which is reflected about the line y equal to x. Okay. So that means all points now will change. Earlier if x coordinate was non-zero and y coordinate was 0, now the y coordinate will be non-zero, x coordinate will be 0. That way we can also understand it, or we can also understand it using the pattern that we have already observed, that focus must be at a distance of AE from the origin, from the center, vertex must be at a distance of A, directrix, foot of the directrix must be at a distance of A by E. So we can use that idea and also derive all these points. Okay. So I think this is just the repetition of the same thing. So you can just take a note of this or take a snapshot and we can move on. Okay. And the next page also. Okay. So can we move on now? So earlier in focal distance we had x1 here, now y1 will come because whatever is the major axis, that is our reference. Okay. Okay, so we can move on now. Now this is one shifted form. So again same funda. When it comes to equations, x minus h, y minus k will come, that means h and k will get subtracted. When it comes to points, they get added. Okay. But focal distance will follow the equation pattern. So in place of y, we have y minus k. Okay. So this is the overall pattern and overall basic theory of these standard forms. Okay. Now based on these ideas, let us also build another idea for the general equation. Okay. Now for all the setup that we have discussed till now, one special case was the center was at origin, the other special case was center was at some other point, but axes of the ellipse were parallel to x axis and y axis. But what if it is not? If we have taken one, let us say general ellipse like this, okay, then how do we understand the situation there? And based on the factors like A, B, C, H, G, F, can we predict its center or the axis? That we will discuss once. Okay. Okay, so now this equation is called as the general equation of second degree in two variables. Now this equation may represent pair of straight lines, circles, ellipse, parabola, hyperbola or anything, but it will represent ellipse if this condition is satisfied and also another condition is satisfied. Okay. So here it is a two-way statement. Okay. So if this is representing ellipse, then this condition must be satisfied. Okay. But can we do the converse? Converse means if this condition is satisfied, will this equation represent ellipse? No. Why? Because the delta must be not equal to 0. Now what is delta? I hope you remember that we sent all hot girls having boyfriends to cinema. We sent all of them. Okay. You remember that determinant? All hot girls having boyfriends go for cinema. Now if this determinant is equal to 0, it represents pair of straight lines. If it is not equal to 0, only then we can think about the conics. Okay. So this statement is right, but the converse is not right. So for the converse to be true, we have to put another condition that this delta must not be 0. If this is valid, then it gives ellipse. Okay. But if it is already representing ellipse, then this must be valid, this also must be valid. So that way this statement is right, but the converse is not right. Okay. Okay. So this is a two-way statement. You have to understand that two-way statement, especially in maths. Sometimes A implies B does not mean B implies A. Okay. Okay. Now coming to the special cases. If it is already if it is already representing an ellipse and then if h is 0, it means the axes of the ellipse are parallel to the coordinate axis. So if h is 0, then what does it mean? It means the xy term is absent. If xy term is absent, then we can say that the axes of the ellipse are parallel to the coordinate axis. Now if it is already representing ellipse and if g and f both are 0, that means these two terms are absent, we can say that the center of the conic is origin. In fact, this is true for hyperbola also. Okay. These two statements are true for hyperbola also. So if it represents hyperbola, then if h is 0, then axes are parallel to coordinate axis. If g and f are 0, then that means center is the origin. Okay. So but all these are valid only if it represents ellipse. For that to represent ellipse, these two conditions must be satisfied. Okay. So quickly take a note of this, then we will start solving some problems on these basic ideas. Okay. Okay. Now, let us solve some basic problems based on the concepts that we have learned till now. Now, first question, length of lattice rectum of ellipse is equal to length of semi-minor axis. Now, we know that major axis is 2a, so semi-major axis becomes half of it, which is a. Minor axis is 2b, that means length of minor axis. Now, semi-minor axis becomes b, half of it. So, here to solve this question, which ellipse do we want to take? We can take any ellipse that we want or that we are comfortable with. What is the ellipse that we are most comfortable with? With this ellipse, x square by a square plus y square by b square is equal to 1. We are most comfortable with this ellipse. Now, when we try to understand the setup, these two are the foci and this is the minor axis, this is the major axis. And what is given here? Length of lattice rectum. If we take the major axis as 2a and minor axis as 2b, then lattice rectum is 2b square by a. This must be equal to what is given? Length of semi-minor axis. What is semi-minor axis here? Half of 2b is b, so this must be equal to b. Now, this is the given information, we have to find out eccentricity. Okay. So, now why did I take the standard ellipse which has center at origin? Because of the simplicity. For problem solving, we always take the standard forms. Okay. So, now further what do? We just perform the calculation. Okay. We know that b square by a square b square by a square is going to be 1 minus e square and we want to use it here. So, here luckily 1b is getting cancelled and we got 2 into b by a is equal to 1, but if I square it, what do I get? 2 into b by a whole square is 1. So, which means 4 into 1 minus e square is 1. Now, we want to solve for e square here. So, send 4 here, it becomes 1 by 4. Now, flip e square and 1. So, 1 minus 1 by 4 will become e square. Okay. So, that means e will become root of 3 by 2, that will be the eccentricity of this problem. Okay. So, this way we can solve it. You can definitely take a note of this. Okay. Now, can we proceed to the next problem? So, here if foci and end of minor axis, okay, so it must be one end or an end. Okay. So, if foci and end of one end of minor axis form an equilateral triangle, then find E. So, here also question is about only eccentricity, it is not about which ellipse. So, we can take the standard ellipse. So, let us say we have taken one ellipse here. Okay. So, let us say we have taken one ellipse here. Okay. So, it looks like an ellipse, yes. So, let us say this is my, these are my foci and this is the end of minor axis. Now, when I join this point with these 2 points, this triangle must become one equilateral triangle. Now, we know that because it is already symmetric, it is on one of the axes of the symmetry, these two are going to be equal, we know that. Now, for this to become an equilateral triangle, it must be equal to this also. So, let us directly equate these two, we will get the required answer. And we know that this point is minus AE comma 0, this point is AE comma 0. Now, distance between these two will become 2AE and this point is 0 comma B. So, we can directly apply the distance formula and solve it. So, what is the distance formula for these two? Because fortunately these points are on x axis and y axis, we can straight away take the squares of these two. Okay. So, it becomes AE minus AE whole square plus B square equal to 2AE whole square. Now, if we just solve it, we will get E. Okay. So, let us simplify this. So, we get B square equal to 3A square E square, because here already we have 4A square and here we have 1A square C square. This is 4a square e square, this is 1 a square e square, so difference is 3a square e square. And we know that b square by a square, that means I have taken one a square to this side, is already 1 minus e square, but here it is coming out to be 3e square. So now that means e square is coming out to be 1 by 4, so e must be 1 by 2. Can we say that e is equal to minus 1 by 2? No, we can't. Eccentricity cannot be a negative value, it's a positive value. Okay. So if you are solving algebraically and if you end up with two roots like this, you should know which one to reject and which one to accept. Okay. So in this question the answer is going to be equal to 1 by 2. Okay. Now can we move on to the next question? If the circle on the join of foci, what is the meaning of join? It means the line segment which is the joining two points. So for a join means line segment. Okay. So if the circle on the join of foci as diameter touches the ellipse, so that means let us say I have taken one ellipse here. Okay. See, because I have changed the pen, we are not getting ellipse properly. Okay, so let us say this is the ellipse. Okay. Now this is my major axis. These are 2 points. Now by taking these 2 points as the diametrically opposite points, if I draw a circle, let us say I have drawn a circle here. Okay. Now this circle must touch the ellipse at a point, and that point also must be the point of symmetry. Why? Because circle is a diagram of symmetry, ellipse is also a diagram of symmetry, and the diametrically opposite points that we have taken are also symmetric about y-axis. So the point of touching must happen on y-axis only. That means that point must be the end of minor axis. Similarly, the point of touching below also must be the end of minor axis. Now, using this situation, can we find E? Of course, we can, because if I join this point with the foci, this point must form 90 degrees here, because diameter makes 90 degrees on the circumference. So now what is the idea? We know the next idea. So if I take the slopes here and take the product of the slopes, it becomes minus 1. This is faster idea than going for the distances. Okay. So you can also go for the distances and simplify, but this must be enough. Okay. So what do we get here? So this is 0 comma b, this is minus ae comma 0, and this point is ae comma 0. So if I go for the slopes here, so we get b minus 0 by 0 minus minus ae, that means 0 plus ae, into b minus 0 by 0 minus ae, this must be equal to minus 1. So if I simplify this, I get b square equal to a square into e square, and we know that b square by a square is 1 minus e square. So we get 1 minus e square equal to e square, which means e must be equal to 1 by root 2. This way we can solve the problem. Or we can also solve the problem the other way, because we know that this angle is 90 degrees. We can also apply Pythagoras theorem here and write a statement using the earlier question. So here this distance, this is basically this distance, and this distance is also going to be same, and here if the angle is 90 degrees, so this square plus this square equal to hypotenuse square. So that means this into 2 must give you the required value. This way also we can get the eccentricity. Okay. So this is also a method, whichever is comfortable to you, you can use it. Okay. Okay, next. An ellipse with which has these two foci and passes through the origin, find E. So basically we have two random points. Okay. So these are the foci. So let me take one ellipse here. Okay. So let us say there is an ellipse like this, and there are two points here which are given as foci, and also it is given that origin lies on the ellipse. Now using this relation we have to find E, but we know that distance between foci must be 2AE, and if this point is, let us say O, this is S dash. Now because the point is on the ellipse, OS plus OS dash must be equal to 2A. So OS plus OS dash must be equal to 2A and SS dash must be equal to 2AE. That means if I take the ratio of these two, I can get eccentricity. So that is the main step here. So let us just get these distances and apply. Okay. Now what is SS dash? That is the distance between the points. So distance between these 2 points, we can apply the distance formula and get it. So here root of 5 minus 3 whole square plus 12 minus 4 whole square. This will give us root of 2 square plus 8 square. So if I take 2 common, so it will become 2 square common, so it will become 2. So 1 plus 4 square, which is root 17. And similarly, what about 2A? Just get the distances of these 2 points from the origin. Now from the origin getting distances is very silly, because 3 and 4 are Pythagoras triplets, part of Pythagoras triplets. So root of 3 square plus 4 square is 5. The moment I looked at these numbers, I got the distance in my mind, that one distance is going to be 5, other is going to be 13. Why is it? Because they are Pythagoras triplets. Okay. So basically the 2A is going to be root of 3 square plus 5 square plus root of 5 square plus 12 square. Because I remember these numbers, this becomes, this is 3 square plus 4 square. So this becomes 5 plus 13, which is same as 18. Now if I just take the ratio of these two, I will get E. So that means I just have to take the ratio. So E equal to 2 root 17 by 18, which is same as root 17 by 9. So the answer to this question is root 17 by 9. Okay. Can we move on to the next question now? Okay. Next, find the vertices, foci, directrix and latus rectum of the ellipse using this equation. Okay. So how do we do this? So first of all, observe that xy terms are present, but also observe that x into y term is absent. So that means the axes of the ellipse are parallel to x and y axis. So basically this equation can be converted into this form: x minus h whole square by a square plus y minus k whole square by b square must be equal to 1. We can convert this equation into this form. That is the main idea. Now how do we convert? By using completing square method. So let me just take all terms of x together and all terms of y together. So these are 2 terms with x and these are 2 terms with y. So let us separate these terms. Now from these 2 terms, if I take 9 common, I get x square minus 2x. Now plus from these 2 terms, if I take 25 common, I get y square minus 4y. Now I am leaving some space there, and in RHS we have 116. Okay. So now what to do here? Just add and subtract some numbers. Okay. So here I will just add 1. Why? Because it becomes x minus 1 whole square. Here I will add 4. Why? Because it becomes y minus 2 whole square. But because these terms were not there and provided me by as extra, so these are provided by me as extra, I have to balance them. Okay. So that means in the RHS I have to add 1 9 and also I have to add 25 into 4, which is 100. Okay. So now let us simplify this. Okay. So these are what we got till now. Okay. Now what about RHS? RHS comes out to be, see, 16 plus 9 is 25. So 125 plus 100 is 225, and we know that 225 is 9 into 25. So, we can divide with 9 into 25 both sides and convert this into an equation like this: x minus 1 square by 25 plus y minus 2 square by 9 equal to 1. Now, this is not looking like a square and b square, we have to design a square and b square now. Okay. So, out of these two numbers, which is bigger? 25 is bigger. So, the major axis is going to be parallel to x axis. So, the situation will be somewhat like this. Okay. So, we will have one ellipse like this whose major axis is parallel to x axis. Suppose if 25 came here and 9 came with x minus 1, then it must be a vertical ellipse. Okay. So, now in this we know that the center is the point where these both terms become 0. So, x equal to 1 and y equal to 2 is the center. So, here we can take the point as 1 comma 2. Okay. Now, we know the a here, a is 5 units and b is 3 units. What about e? We can directly get e as 1 minus b square by a square. So, 1 minus 9 by 25 whole root, that becomes 16 by 25 whole root, which is 4 by 5. Okay. So, what about a? A into e becomes 5 into 4 by 5, which is 4. What about a by e? A by e becomes 25 by 4. Okay. Now, we know the setup. Focus must be ae comma 0 because we shifted it to 1 comma 2, 1 and 2 must be added. Okay. So, whatever is required we can directly calculate based on this idea. Okay. So, what is the lattice rectum? It is 2b square by a, we can straight away get it, 2 into 9 by 25, that will be the lattice rectum. Okay. So, this part is easy. Vertices, foci, directrix can be calculated using these ideas. Okay. So, let me just take them to the next page, but because we are short of time, so let us just skip that part, but you know how to evaluate these. Okay. So, you complete this problem, and if you have any problem, if you are facing any issue, then pass a comment or ask us a doubt in the platform. We will be there to solve it anytime. Okay. Next, C1 and C2 are two fixed circles, okay, with radii R1 and R2 such that C2 is contained in C1. A third circle C moves in such a way that it touches C1 internally and C2 externally, then find the locus of its center. I think this language is actually going to confuse you because it is too much language, but we can understand it this way. These are two fixed circles and one circle is inside the other circle. Okay. So, let us just draw some circles here. So, let us say there is one circle here. Okay. So, it looks like a circle, decent. Okay. And there is another circle C1, C2 which is inside this. So, let us say there is another circle which is C2. This is C1 circle, this is C2 circle. Okay. Now, there is one more circle C which is touching C1 internally and C2 externally. So, let us just draw that in a different color. So, let us say there is one circle here. Let us say there is one circle here. Now, this circle is touching C1 internally, C2 externally. Now, what is that we have to find? Find the locus of its center. So, we have to find the locus, but are any coordinates given here? Are any equations given here? No. That means we are not actually interested in the equation of the locus, we are interested in the shape of the locus. If equations are given, then that means we have to find the equation. So, here because equations are not given, we have to only tell the shape. Now, of course, question is asked in the ellipse, so answer should be ellipse, but let me just explain it here. Okay. Okay. So, here suppose let us say we take the center of this variable circle as let us say P, and center of this fixed circle as B, center of this bigger circle as let us say A. Okay. Now, I can get the distance of P from B using the concept of circles. So, if I take this radius as let us say R2 and radius of this C1 as R1. Okay. Now, I can get this PB as PB is equal to, okay, now there is variable circle also, let me take the radius of this variable circle as small r. So, it becomes R plus R1. Out of these two, R is variable, R1 is constant. Now, similarly here R2 is also constant, okay, this must be R2, my mistake, okay. Now, R2 is constant, R1 is constant, but R is variable. Now, if I take distance of P from A, how much will be this distance? Because these two circles are touching internally, and we know that R1 is definitely bigger than R because R is a smaller circle. So, we can say that PA is going to be R1 minus small r, okay. PA is R1 minus small r and PB is R plus R2. Now, we want to find the locus of P, we want to find the shape of the locus of P. So, we will try to generate an equation directly by adding them or subtracting them or whatever is required there. But here coincidentally if we just add them, R gets cancelled because it is a simple algebra, but in some cases it is not addition. So, for that we may have to somehow use some algebra. So, when we add these two we get R1 plus R2, okay, and we know that R1 is constant, R2 is constant. So, hence R1 plus R2 is constant, PA plus PB is constant. Will it give a locus which is ellipse? It may give if the constant is greater than AB. So, it is necessary that we also calculate AB. So, if I calculate this distance AB, then this distance is definitely less than R1 only, because this center, this circle, second circle is already lying inside the first circle. So, this is definitely, this distance is definitely less than R1. So, this constant is definitely greater than AB, hence it is an ellipse. Okay. So, this way we can find out the shape of the locus of the center. Okay. So, basically if you look at all these questions, we have only applied basic ideas and solved these questions. Okay. So, with this question I will complete today's lecture, we will close the first lecture here. So, what have we learned in the today's lecture? We have learned the basic definition, basic ideas, standard setup, standard equations, and we solved some basic questions on these ideas. We will meet again in the next lecture. I hope you are enjoying my lectures. We will meet again in the next lecture. Until then, have a great learning day. Learning shall never stop.